Alright, in this video I am going to go through all the properties of quadrilaterals, talking about not only their definitions, but what properties they have associated with them. We'll talk about some that have properties in common and a lot of the nuanced distinctions between the types of quadrilaterals. So on your screen right now is basically a tree diagram of how the basic quadrilaterals sort of fit together. And over here to your left you see we've got parallelograms, and underneath parallelograms we've got rectangles, we've got rhombuses or rhombi, and we've got squares. And right here we've got a trapezoid, right? Because a trapezoid is not a parallelogram. It can't be a parallelogram. And underneath that we've got isosceles trapezoids, and sometimes we'll have right trapezoids, which we'll take a look at later. And then we've got this guy over here, a kite, which has a very distinct definition and has some very distinct properties. And one thing that it's kind of rare to think about this, but technically I suppose a kite can turn into a rhombus at a certain point, but for our purposes we'll just kind of leave it over there for now, since it is kind of a very unique quadrilateral. But let's start with some definitions, right? A quadrilateral by itself is nothing really all that special. It's just a four-sided polygon that's enclosed. It doesn't have any curves or anything. And there are lots of different types of quadrilaterals. Some of them are special, some of them aren't so special. Alright, the most special, I think, kind of quadrilateral is a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. Alright, inside parallelograms we've got rectangles. A rectangle is a parallelogram with all four angles congruent. We've got a rhombus, which is a parallelogram with all four sides congruent. So you can see that a rectangle and a rhombus, angles congruent, sides congruent, angles congruent, sides congruent. And then finally a square is essentially a combination of the two. It's a parallelogram that has all four sides and all four angles congruent. Over here we've got a trapezoid, right? It's quadrilateral with only one pair of opposite sides that are parallel. We'll call these the bases, base sub 1, base sub 2. If you're isosceles and you're a trapezoid, you've got congruent legs and congruent base angles. And if you're a kite, you are a four-sided polygon that has two pairs of consecutive sides that are congruent. And we'll take a look at that more in a few minutes. So let's get some pictures here. Right, quadrilaterals can look like a lot of things, right? It can be a rectangle, what we commonly think of as a rectangle. It can be this thing, what we commonly probably think of as a square. It can be this thing, essentially just a square tilted on its side, which is something that we can call a rhombus. You can also call this, right here, you can probably also call this a rectangle, maybe even this a rectangle. So there's some overlap here depending on the angles and sides. Sometimes quadrilaterals aren't so special though. This is just a regular old convex quadrilateral, where the angles are nothing really special about them. They're not 90 degrees. They're not these two are not supplementary angles. The opposite angles are not congruent. Over here this is just a concave quadrilateral. You can see that it's kind of like bent in on itself. And again, nothing really super special about those angles. The only thing that is true of all of them, and we'll get to this in our next video, is that all the angles, the interior angles of every single quadrilateral, no matter what you look like, add up to 360. Alright. If you're a parallelogram, you are essentially one of these four types. Alright, let's start on the right side. If you're just a regular old parallelogram, you're kind of tilted. You've got opposite sides that are parallel, which is what the arrows mean. So we got one arrow, and two and two. And we have opposite sides that are congruent as a property. So one tick mark, two tick marks, two tick marks. All right, notice these angles don't have to be 90. What What does have to be true, though, if we think back to our parallel lines cut by a transversal, these angles have to add up to 180. Because we're dealing with parallel lines and this is a transversal that comes through there, we have what we call, I guess, consecutive interior angles. And those are supplementary. Right, over here, let's start with a rectangle on the left side now. If you're a rectangle, your definition is that you have all angles the same. Notice you don't have to have all four sides the same. You can, but you don't have to. Alright, so the two tick marks are the same, the 1 and 1 are the same. If you're a square, you've got all the angles the same and all the sides the same. If you're a rhombus, you have all the sides that are the same. You can be a rhombus and not have right angles. Alright, so and the last thing that we're going to look at is when we draw in diagonals. Now diagonals are basically when we take let me draw this in maybe black or something. Diagonals are basically when we draw in segments that go from vertex to non-consecutive vertex. So these are diagonals. These are diagonals over here. Right, they're kind of tricky to draw. Right, the square has diagonals, and of course a rectangle does too. Oop, that last one was kind of off there, but anyway, in all of these cases, and we'll take a look at this more in a bit, each of these diagonals cuts the other one in half. So these are all congruent to each other. Well, I shouldn't say that they're congruent to each other, but this one is congruent to this one, and this one is congruent to this one. All right. If you're in a square, you are actually all congruent. We'll come back to that in a moment. All right. So there's some basic pictures for you. If you're a rectangle, all right, you've got all those previous properties of parallelograms, and now we're getting into some really key information, piece of information here. Your diagonals, if we were to draw those in, so diagonals, of course, go from here to here, right? Those must be exactly the same. So if we were to put letters here, A, B, C, and D, we would say that the length of segment AC is the same as the length of segment BD. And all the angles must be 90 degrees, right? That's pretty obvious. Okay. If you're a square, all right, you've got all the rectangle properties and your diagonals. So you're a rectangle and your diagonals, which I'll draw in here, your diagonals must be perpendicular to each other. There's a right angle at all these corners. And they must bisect opposite interior angles. We'll come back and look at a better picture of this in a moment, but it's basically cutting all these angles in half. Alright, the rectangles don't have that. Alright, if you're a rhombus, you've got pretty much all the previous properties of squares. However, your interior angles don't have to be 90. So this in here doesn't have to be 90 degrees. It can, but it doesn't have to be 90. Here's a really good example. Alright, this is a rhombus because all the sides are the same, but you know, let's say that this angle is 50 degrees. If that's 50, then this is not 50, of course. It's got to be 130 because these two are consecutive. We know that these are parallel lines, and this is kind of like our transversal here. So we've got kind of like a transversal that cuts through, and that is basically making up what we would probably think of as consecutive interior angles, 50 and 130. Right? So a rhombus can kind of be stretched out more like a diamond, like that. All right, let's get on the trapezoids now. Trapezoids are, again, not parallelograms. Very important that you know that. These are not parallelograms. That's kind of like I guess like the universal symbol for parallelogram, right? In general, if we want to pluralize something, we just put an S in the middle. So trapezoids are not parallelograms because they're both pairs of opposite sides are not parallel. We've got one pair of sides that are parallel. We call these the bases. This side over here is not parallel to this side over here. Alright, so that's just kind of like an ordinary trapezoid. This is an isosceles trapezoid, which has legs that are congruent, and these base angles, this angle up here and this angle up here, are called base angles, and these angles are base angles as well. Alright, and you'll notice again that since we're dealing with a parallelogram and it's kind of like a transversal that goes here, we've got top and bottom base angles that add up to 180. Alright, they're supplementary. Sometimes you'll see a right trapezoid as well. If you're a right trapezoid, you've got these two right angles in here, and you've got one obtuse angle, and you've got one acute angle. Alright, so if you are an isosceles trapezoid, you have all the trapezoid properties in addition to a couple other things, right? We've got legs that are congruent. We've got base angles that are congruent. So if this is, let's say 60 degrees, this has to be 60 degrees. Alright, we've said that if that's 60, then this one's got to be the supplement, so that's got to be 120. Well, that one's 120 as well. And the diagonals must be congruent in an isosceles trapezoid. We'll come back to that in a moment. I'll draw a separate picture. If you're a right trapezoid, you have all the trapezoid properties. However, you've got one leg. This is a leg, of course. You've got one leg that is perpendicular to both bases. Alright, if you're a kite, you are kind of like a little strange little guy here. We've got one pair of opposite angles that are congruent, and you can see them right here. And they're always going to be the angles that come in between the non-congruent sides. So if this angle right here is 100 degrees, so is this. You've got two pairs of consecutive sides that are congruent. So right down here, if this is 9 centimeters, consecutive side is the same. And this can be 5 centimeters or whatever. This has to be the same. Alright, so these are consecutive sides. These are next to each other. They're consecutive, okay? Your diagonals must be perpendicular. We'll see that in a second. As you know, perpendicular means that they intersect at 90-degree angles. And if there's one 90-degree angle, that means they're all 90. You don't ever really draw all four boxes, though. It kind of looks silly. And again, we'll come back to the diagonals in a second, but one of them must bisect a pair of opposite angles, and one of them must bisect the other diagonal. Alright, rectangles with diagonals. We've got diagonals are congruent. Alright, so this is pretty important. Right? Rectangles are one of those figures, along with isosceles trapezoids, and squares, of course, that have congruent diagonals. It's really, really important to know that. So if we were to just look at this again, segment AC is the same as segment BD. Alright, we've already said that they bisect each other. That's true of all parallelograms. So we've got 4 congruent segments. From B to E is the same as from E to D, which is the same as from E to C, and from A to E. They're all the same. So if that's 7, that's 7, that's 7, and that's 7. Alright, notice these diagonals actually don't have to cut these angles in half. This angle is not necessarily bisected by the diagonal. And these angles in here, not necessarily 90 degrees. They can be if you're a special type of rectangle, which is called a square, of course. So if you're a square, you've got congruent diagonals, of course, right? Segment AC. It's pretty easy to see that segment AC is the same length as segment BD. But in addition to that, the angle in here is 90, so it's 90 all the way around here, and these angles are all bisected. Alright, it just so happens that they're 45 degrees. Alright, 45 all the way around, all the way around. Alright, if you're a rhombus, you're a really interesting fellow. This is, of course, we know a rhombus is a parallelogram that has all sides congruent. So segment AD is equal to DC is equal to CB and BA. Alright, so you're basically a square, except your angles don't have to be 90. They can be. And you also have some exceptions here from a square. The length of segment BD, this right here, that diagonal does not have to equal segment AC. They're not required to be congruent. They do bisect each other though, so if we were to put letter E in here, segment DE is the same as EB, and AE is the same as EC. They bisect each other, but they're not congruent themselves. And the angles, which is pretty obvious, the angles right here, this angle DAB is not the same as this angle. Clearly, this angle looks like it's obtuse, and this angle right here looks like it's acute. But they are bisected. So if we were to say, this thing were 20 degrees, this one would be 20 degrees. And so that's 40 altogether. So that's 40 altogether. This one altogether has to be 140, so that would be 70 and 70. So 20, 20, 70, 70. All right, if you're just a kind of an ordinary old trapezoid, right, you don't really have any special properties as far as your diagonals go. Nothing super special about them. If you're an isosceles trapezoid, however, you do have some pretty important properties. We've got segment DB and segment AC are congruent, right? The diagonals are congruent, really important. Also, since they are congruent, right, and they are intersecting at point E, we can say that segment DE and segment EC are the same. Similarly, AE and EB are congruent. Alright, so isosceles trapezoid is one of those things that we definitely know the diagonals are the same. And again, it's pretty easy to see that this angle isn't necessarily equal to this angle. Right? So the diagonals don't bisect opposite angles, but they are congruent themselves. Alright, if you're a kite, all right, last one here, we've got, as I said earlier, we've got pretty interesting diagonals. We've got diagonals that are always 90 degrees, always perpendicular. And this diagonal AC, is a bisector. It's not only an angle bisector, but it's there's the bell, sorry. It's a segment bisector as well. It cuts the vertical diagonal in half. Right, so if this were like 4 centimeters, this would be 2. Notice this doesn't have to be the same as this though. Alright, these angles over here are the same, and these angles are the same, but they don't have to be equal to each other. Alright, so those are some quadrilateral properties. I hope it helped you, and in the next video we'll take a look at this quadrilateral sum theorem.